Okay, so in this video, we're going to continue our unit on solving equations, and specifically, we're going to talk about solving a rational equation in this video. So hopefully you recognize that word rational from previously in our class. In the very first unit, we talked about rational numbers. As we were learning how to simplify different kinds of expressions, we learned about rational expressions. Now we're going to learn about rational equations. Coming soon to a math class near you, we're going to study rational functions, and we're going to graph rational expressions or rational functions as well. So there's a lot of things in our class that deal with this idea of rational. So if you don't recognize that word yet, then that's definitely something that you should start studying a little bit. You should connect that word rational with the idea of fractions. That's what we're talking about. In this particular video, we're going to solve equations that have fractions where the variable is in the denominator of the fraction. So with that said, let's go ahead and take a look at our learning objectives, and then we'll get started. We basically have two learning objectives. The first one is to actually solve equations. There's a variety of different techniques that you might use to solve rational equations. In this particular class, I'm going to focus on the technique of cross multiplying. Remember, you can always use a different method than what I show you, as long as it's legal, correct mathematics. But in this case, what I'll be showing you is cross multiplication. That's a method that you learned probably back in middle school, so hopefully it should feel a little bit familiar. The other thing we're going to talk about is the need to check answers. You know, usually algebra works so nicely that as long as you're careful and you add correctly and all that kind of stuff, when you're done, you end up with an answer that you know is correct, and life is fine and good and wonderful. But unfortunately, with rational equations, that doesn't always happen. You can do all of your algebra completely perfect and still get an answer that doesn't work. So it's absolutely vital that you check your answers. And we'll talk a little bit about that. So those are our learning objectives, okay? In fact, let's do these learning objectives in reverse. Let's start with the need to check answers. So as I mentioned just a second ago, it's possible to do all of your algebra completely correct and end up with an answer that does not work. When that happens, the answer that does not work is called an extraneous solution. Extraneous solution. Now that is a word that we will use in our class. So solution, there we go. That's a word that we'll use in our class, or a phrase, extraneous solution. So that's a phrase that you'll definitely want to make sure you have a working understanding of what that means. It probably won't show up as a vocabulary question on a test or anything, but when the directions say identify extraneous solutions, you need to recognize what it's asking you to do is find solutions to the equation and then specifically recognize the ones that don't work, if there are any, okay? So an extraneous solution, and this is not a super formal math definition, but like I said, we just need a working idea of what this is. An extraneous solution is a solution to an equation, that is found using, whoops, that's not how you spell using, using correct mathematical or correct math practices. Let's say that, correct math practices. In other words, you're going through and solving an equation, and everything you do is mathematically correct. So you've done the right order of operations. You've used the right procedures. You have not made any arithmetic mistakes. Everything you've done is correct. And you end up with this solution, a solution to an equation found using correct math practices. So everything you've done is correct, but that solution does not work as a solution to the equation, in the equation. In other words, when you plug it back in, you get something that doesn't make sense. Like you plug it back in and you simplify and you end up with 6 equals -9 or something like that, okay? That would be an extraneous solution. So we check for extraneous solutions by plugging your answer in when you're done. Whoops, by substituting answers back into equations. Okay, so this is something that can happen anytime you're solving a rational equation. Now, the reason why this happened is beyond the scope of our class, but it's not like algebra is fundamentally flawed. There's just a couple little minor issues that happen sometimes. So because we're not going to talk about the reasons behind this, it's necessary that you just always check. Always check, because you're not going to know for sure what situation would cause it to happen and what situations wouldn't. Okay, so that's the idea of an extraneous solution. So like I said, you need to recognize this phrase, especially when you see it in the directions on homework or on a test or something like that, and know that that means make sure you identify any solutions that you found but that don't actually work. Okay, so that takes care of learning objective number 2. Now for learning objective number 1, to actually solve equations. We're going to continue with our basic process that we've been talking about for solving equations all along. And this is basically a 2-step process that we usually use. Now, we have seen a couple exceptions to this, but we have this 2-step process that we usually use. Number 1 is we rearrange the parts of the equation to make it look the way we want it to look. And typically speaking, what that means is simplify. Okay, so I'm just going to put simplify. Okay, that's typically what we do. When we studied linear equations, we said we're going to simplify both sides of the equation first. When we studied radical equations, we said the same thing. When we did quadratics, this was a little different. We wanted it not only simplified, but we also wanted it equal to 0. Okay, so but we have this initial step where we're manipulating things to make it look the way we want it to look. And then after that, we have some sort of process to get x by itself. Okay, and again, with linear equations and radical equations, we just simply used inverse operations. So if there was a +3 added on to the x, then we used -3 on both sides of the equation to get the x by itself. With quadratics, we saw there was a different process to get x by itself. We could use factoring, we could use the quadratic formula, but all of those things are things that we did in order to achieve x all alone. Okay, so this is the same basic idea that we're going to use when we solve a rational equation as well. But the way that we will get x by itself is we're going to end up with cross multiplication. So in specifically rational equations, okay, so specifically for rational equations, this first step, making it look the way we want it to look, we want it to be simplified. We want all the parentheses gone, things combined together or whatever. But ultimately, when we're all done simplifying, we're going to want to have one fraction equal to another fraction. Okay, so that's what we're shooting for in that first step. When we're simplifying things down, we want to combine fractions together. Do whatever it needs to get it fully simplified so we have one fraction equal to another fraction. And then to get x alone, what we're going to do is cross multiply and solve. So it basically, those are our 2 main steps. Okay, now we're going to break this down into a couple finer details, but those are our 2 main steps. That's the basic process that we're going to have to these. All right, so with that all said as background, let's take a look at an example. So here's example number 1. And for example number 1, we're going to solve 4 divided by x plus 1 equal to 3 over x. Okay. 4 divided by x plus 1 equal to 3 over x. Okay, and over here I'm going to outline our steps or our procedure, our process that we're going to use. Okay, So like I said, step one is we want to completely simplify everything and then rearrange it so that we have one fraction equal to another fraction. So that's the way that we're going to start rational expressions. Now, in this case, we already have that. I've got this fraction. It's all simplified. There's no parentheses, nothing. Life is good. Same thing over here, all simplified, no parentheses. So I have one fraction equal to another fraction. Life is great. Now, to get x by itself, the first thing we're going to do is cross multiply. So cross multiply, you might remember, is a property that these types of equations have. These equations, by the way, were called, oh, I just lost the word, starts with a P, proportions. Sorry about that. So when you learn how to solve proportions back in middle school, you learned that they have this property that if you multiply across the equal sign diagonally, so I would multiply those two things together, 4 times x, and multiply across the equal sign diagonally in the other direction. So multiplying these things together, 3 times x plus 1, proportions have this property that if these two things were equal to start with, then these two things are still equal now. Okay, and so that's what we're talking about when we say cross multiply. And once we cross multiply, notice what I have here now is I have an equation that's linear. So at this point, we just go back and we solve the linear equation. Okay, solve the new equation. And this new equation was linear. So the way that we solved linear equations was we simplified both sides. So I'm going to multiply 4 times x. That gives me 4x. And I'm going to distribute my 3. So that gives me a 3x plus 3. So that would be my first step. And then I'm going to get the x's collected together on one side of the equation. So I'll subtract 3x from both sides. 4x minus 3x is a 1x, but I'm just going to make the 1 a sneaky ninja. 3x minus 3x cancels. That leaves me with a positive 3. And now my x is all by itself equal to a number. And so I'm done. So these become our basic steps. Now, I do want to say one thing. In this first video, we're only looking at the most simple type of equation. And so this is the most simple type of equation. In the next video, the one that's going to come after this, solving this new equation will be a little more complicated. So once you cross multiply, you're going to have a little bit more work to go to get down to the end. And then in the final video of this series, the first step is going to be more complicated. You're going to have more than just this to start with, and you're going to have to do some more significant rearranging. So these problems are going to get increasingly difficult as we move on. But here at the beginning, this is basically what we're looking at. Okay, now, if you've been paying close attention in this video, you know right now that there's a small problem with what I've done. Do you recognize what it is? I have not checked my answer. So that's my last step, is to check for an extraneous solution. So the way that I check is I always go back to the original equation. I always go back to the original equation. I always go back to the original equation. That's the equation I'm going to use. And then everywhere there's an x, I'm going to substitute in 3. And remember, we've talked about all year long, when I substitute, I'm going to use parentheses. It turns out on this particular problem that the parentheses are not needed, but I'm going to do that anyway. I will always use parentheses when I substitute. So now 3, the parentheses don't really do anything. So I have 3 plus 1. 3 plus 1 is equal to 4. And 4 divided by 4 is equal to 1. So the left-hand side simplifies down to be just a 1. I've got my equals in the middle. And on the right-hand side, I just simplify this down. Again, that parenthesis doesn't really matter. So this is just the same as 3 over 3. 3 over 3 equals 1. So now that side is simplified. And then I just check. Once I get both sides simplified, is this statement that I end up with true? Does 1 equal 1? And yes, of course it does. So that means this solution was not extraneous. It works when I plug it back in. So this is my answer. Now, I do want you to notice real quick, as far as the way your paper will look on these types of problems, perhaps this is unusual from what you're used to. I've got a bunch of work, I've got my answer, and then I have a bunch of work, okay? With these types of problems, because it's so important that you always check your answer is always going to end up in the middle of your page with work before it, where you're finding the answer, and work after it, where you're checking the answer. So your answer should always end up in the middle of the page with these types of problems. Okay, so that's our basic idea. That's our basic process. Like I said, in this first video, it's not going to get much more complicated than this particular example right here. So I'm going to stop the video right now, give you a chance to try some practice problems. Like always, if you're having trouble, let me know and I will try to help. But this is the type of problem that we're going to begin our course with. All right, so thanks for watching. Have a good one.